What is going on, everyone? And welcome to a new episode. Today we are going to be doing the renderer and the sprite renderer. And I miscounted my weeks, so I was going to do FBOs next week and realized that this is, well, the last time I'm recording until January. So I'm going to try to hurry up and toss that into this episode as well. So if I'm not explaining all that clearly or whatever, that's the reason why, is I'm going to try to jam FBOs into this episode as well. So to make things a little bit faster, I went ahead and updated like my material file, or no, I didn't change anything in the material file. The sprite file, I just gave myself an actual sprite. And this padding, I think we're gonna remove that later, because I don't know why I added that, but I don't want to mess with it right now because I don't want to take up too much time. So I did notice when I was kind of goofing around a few minutes ago is, where is it? Right here. That we never actually unbind the shader. We unbind the mesh, but not the shader. So I'm going to do shader dot unbind. In the GUI class, all the way at the bottom. Alright, so the first thing that we're going to need to do is you're going to need a renderer class. We're also going to need a SpriteRenderer class. And we're going to need an FBO class. So, FBO. There we go. Alright, so I've kind of explained it before, but SpriteRenderer is going to be the actual class that that is going to be attached to the sprite, or the object that is going to be rendering the sprite. So that's the FBO class. So here it needs to be extends and then logic behavior. And all it's really going to have in here is the sprite that it needs to be rendering. For now, at least. Actually, gonna need we're gonna need a scale as well. So let's do private vector 2 scale. Import that. Alright, so the only function that we're going to use for now is going to be set uniforms. And what set uniforms is going to do is it's just going to set the uniforms required by this sprite. So we're going to say sprite.material.shader.setUniform. And then the name, I'm going to do screen pos, because we're remember that we're using the shader that we made for for the GUI for now, just to get it rendering onto the screen. So we're going to pass in the X position and the Y position of the game object. And then we need to set the scale. So, what am I doing? Game object scale. So basically that's the reason why I put this up here, is so that whenever I set the uniforms, I'm just caching this. It just makes it a little bit less intensive, not by much because it doesn't really do much, but at the same time it's good. And then we need to set another uniform, which is going to be the pixel scale. And the pixel scale is going to be sprite.offset.width, and then we need to multiply this by scale.x. And then the same thing here, we're going to go sprite.offset.height multiplied by scale.y. And that's it for setting the scale. Now we need a way to get a UV. It's going to be sprite.uv, and apparently we didn't add that function yet. I was going to and just didn't get around to actually doing it. And of course, as you can tell with all this Thanksgiving stuff going on, I wasn't even able to update these notes. Alright, so what this is going to do is it's basically just going to give us the UV coordinates of the cached rectangle that we have. So what it's going to be is it's going to be a public rect UV, not UVC. And then we're going to say if offset equals null, then we're going to return out of it. And there. Need to return null. So it's not going to return any UVs, or it's going to return a null UV if there is no offset. And I don't think we have vector 2's coming out of textures getting the size, so we need float w equals material dot texture dot width, and float h equals material dot texture dot height. That way we can have that cache, because we need to use it a couple times. So we need to return a new rect. It's going to be offset dot x divided by w, and then offset dot y divided by h, offset dot width divided by w, and then offset dot height divided by h. So that's pretty simple, and that will give us the UV coordinates of our rectangle. And the reason why we're putting this in a function instead of caching it like how we do some of the other classes, we actually cache the UV coordinates is because since this is public and you're able to change it in the editor, there is no way to cache those UVs, because those UVs are going to change. So whenever we call this function, it's going to just return a UV coordinate set. Alright, so then back in here, why did I say, oh, because I didn't put an equal sign. Alright, so now we have the UVs. So once we have the UVs, now we need to send it to the shader. So it's sprite.material.shader.setUniform, and then we called this offset, I believe. And then uv.x, uv.y, uv.width, and uv.height. And later on we're going to add a vector 4 set uniform thing and a vector 2 set uniform. Well, vector 2 multiplication and stuff like that, just so that we don't have to write all this crap out. We could just say the width of the sprite times the scale instead of xy and xy width height, because all that crap gets really annoying. So at the beginning of the year, we're going to fix all this. So we're going to add some multiplication to the to all these things, just so that we don't have to mess with all that anymore. All right, and so now we can do the renderer, because like how I said before, we're working backwards. So it goes SpriteRenderer and then renderer, and then after renderer it's going to be FBO. So inside of the renderer, it's going to be I did that right. Okay, no, it just came to mind. Alright, so the renderer, it's going to be a static class, and it's just going to hold some of the information like the mesh and stuff like that. And basically we could just call the renderer and it will do everything it needs to do. So we're going to do public static map, which is going to be a hash map. We need it to be material, because we're going to group our material, and then it's going to be a list of SpriteRenderer. And then we'll just call this batch, and then it's going to equal a new hash map of material. I believe I could just put list instead of array list. Whenever we create it down below, we're going to need to turn that into an array list. Create a list. Why is it telling me to create a list? I don't know why you're being stupid. Alright. Here I'm just going to import it manually. Screw it. I don't know why it's not just importing it. List. And map. There. Next we need the actual mesh, because the mesh is going to be different than the than the mesh that we're going to be that we're using for GUI. And then we need a cached projection. All right, so first thing we're going to need is an initialization function. So go public static void init, and that way we can cache the things that we need at the very beginning. So we need to do the mesh. So let's go verts equals new float. And I'm going to cheat really quick. Do I have yes, I have GUI up. And I'm just going to copy these. Copy. Because the verts will stay the same, but the UV coordinates will change. Am I an idiot? What did I do? Oh, it's that equal sign. There. Alright. So, now is the UVs. It's going to be a new float. Hopefully I can get this right the first time. It's going to be 0, 0, 1, 0, and then 1, 1, and 1, 1. So going into the same position. And 0, 1, and 0, 0. Let's make sure that's correct. Okay, I'm pretty sure that's right. And then we're just gonna say mesh equals new mesh, and then pass in the verts, then pass in the UVs. That's it for now. At least until we get FBO set up. And then we need a way to add it to the renderer. So, add to a renderer. And this is going to allow me to send a SpriteRenderer and then batch it up here. So it's like a preparation for rendering method. I'll say list SpriteRenderer. And say mat renderers for material renderers equals batch.get r.sprite.material. And that will get the list associated with that material. So then we're going to say if mat renderers equals null. So if we have not gotten a batch for that material yet, you're going to say, I called it mat renderers. Okay, equals new array list, which I will have to import that as well. of SpriteRenderer. So we're basically just going to create a new array list for it, and then we're going to put it in there. So batch.put, and then we're putting r.sprite.material, and then we are going to pass in our mat renderers list. And then down here, we want to say mat renderers dot add r, and that will add the sprite renderer to the list that we just batched. And now onto the render method, which is going to be a little janky for now, which we can fix later. Just because I want to try to squeeze all this stuff into this one episode. And then we're going to pass in a rectangle that we want to draw. I'm not going to go super deep into detail, but we want to either be able to render it the whole screen or render a portion like this right here. And that's going to work nicely for our editor, but then whenever the editor is not there, we can just pass in the rectangle for the whole application. All right, and here what I need to do is I need to do float half w equals, wait, no, let's do float w equals application dot width, float h equals application dot height, and then we need to do float half w equals w divided by 2, actually w times 0.5f, because multiplying to get half, so if you want half and you multiply it by 0.5, it's actually cheaper than dividing it by 2. Little friendly knowledge there. So that will give us half, so the center of the screen. The reason why we want to do that is because we always want 0, 0 to be the middle of the screen. Some people like it way down here, bottom left, as 0, 0. But for instance, say you have a player in the middle of the screen, you want the screen to follow you. So you would say camera equals player.position or whatever, and it's always going to be centered on the screen. Versus if it's way over here, then you have to like offset by the whole application size, and it's just a big mess. So we're going to do it right in the center. And later we may add an option in the engine that allows us to change the anchor point for whatever a 0, 0. So here we need to create a projection. So say projection equals matrix for 4x4 dot ortho. All right, and this is going to be a little weird, and I'll explain kind of what's going on. So we're going to do negative half w, and then we're going to do half w. And then here we're going to do the exact opposite. We're going to do half h and then negative half h. And then here's going to be just like we do always, -1 and 1. Got near plane at -1, far plane at 1. The reason why this is backwards is because we're going to be rendering the FBO with using GUI. So we actually need to render it upside down onto the FBO, and then whenever the GUI renders it, what it's going to do is it's going to flip it again. So then it's going to be right side up. So it's a little confusing, but it's a lot easier doing it that way. And since we have 0 on GUI way up here, but 0 on rendering regularly, we want it down here. If that makes any sense for you. Okay, let me stop screwing around. All right. Then we need to bind the mesh. And so now we need to say for material for batch.keyset. So we're going to get all the materials and our batched key set. And we're going to bind the material since we added that function that does all that stuff for us. And then we need to set material.shader.set uniform and projection and pass in projection. And then secondly, we need to set the color. So set uniform, and it's matte color, and material color. What am I doing? Material dot color, not material color. Alright, so now we've got these here. Now we need to get the list for the renderers. Renderer. And call it renderers equals batch.get material. And then here we're going to say for every sprite renderer called renderer and renderers, we need to call renderer.set uniforms, that function that we created earlier that will do it for us. And then render the mesh. Why do I keep on trying to do that? Renderer. And then after we're all done with this, we need to unbind the mesh. Wait, no. Unbind the material. That would suck if I'd actually unbind the mesh. Material.unbind, and then right here is where I want to unbind the mesh. So mesh.unbind. Then I need to clear the batch. That way we're ready for another set of batching. Otherwise those lists are going to stay completed, or that hash map is, and it's going to be a big huge mess. And let's see here. Yeah, I believe that's it before FBO. So let's make sure I did this correctly. Let's see. I need to set some of the... I need to add a renderer to the what is it, the Tutti Frutti object. See, G dot add component. Hold on a second. Let me find the fastest way to do this. Okay, that's what I was screwing up with. I was thinking about what to initialize first and was screwing around. Okay, so first we need a texture, which for me I'm wanting to use smw tiles.png. So whatever image that you're going to be using to draw or for your sprite, because we're going to have to import all these things accordingly. That way we have them to be able to render. Later it's all going to be automatic, but right now it is not. So we have to manually do this, just like how we've had to do up here. So new material, what do I call it? Test material, I believe. Yeah, it's right up there. Test material. I don't believe I have to put any dot crap. And then I need to get the sprite. So I'm going to say sprite s equals new sprite. I called it test sprite. And that will import my sprite object and store it as a sprite. Now make sure that you do these before you do the sprite, because if not, then this stuff wouldn't have been imported yet. And that was what was kind of confusing me on what to do first. Alright, and then after this, then we can go ahead and initialize the renderer. So we're going to go renderer.init. And then we're going to do sprite renderer sr equals new sprite renderer. And I've told you guys in previous episodes to not do this first. Like here we're going to go g dot add component and then sr. So I told you not to do this and then put it in there. I told you just to go ahead and put new sprite renderer right here. But since it's not automatic right now, we're going to have to change these values. We're going to have to pass in that sprite. So we need access to that sprite. And I don't want to use get component after I added it, because I already have a reference to it. But I mean, you can also do this in your game as well. Just be careful and make sure that you add it and you're not trying to add it to multiple objects and blah blah blah. So we need to set the sprite. So I'm going to say sr.sprite equals s. And just to make it so it's a little clear, let's go ahead and say g.scale new vector 2, and let's pass in 2. That way it's a little bit bigger because I'm using 16 by 16 sprites. And so it may be kind of small on screen. And down here we can make a kind of temporary thing and just add it, manually add it to the renderer. So renderer dot add to renderer, and then just pass in SR. And then we need to call the render method. So renderer dot render. So the rectangle that we're going to use is new rect 400, because right now we've hard coded the width of the hierarchy and stuff, so it's going to be 400 on each side. So it's going to be 400. Oh, come on. And 0, because we want it all the way at the top. And application dot width minus 800, because we got 400 on each side. Then we're going to do application dot height minus 30, because our debug window is 30 high. And hopefully this works. Hold on just a second. I'm going to figure out what this is. Okay, I see what's going on. I never, inside of the shader class and the constructor, at the very bottom, put shaders dot add this. Because for some reason, there we go. Because for some reason we never added that. This is the list of shaders. So whenever I was trying to find it, it was never actually added. So right now it's rendered upside down, because like I said, the FBO is going to flip it back around because it's going to be rendered with GUI. So there you go, middle of the screen, because we've got it on the corner. And if we go in here, we can make it bigger if my computer will not stall out. Why did you just do that? Okay. So we can make it bigger. We can offset its position, say 25. So all this works. But right now, let's put this at 500. See, it's going to be rendering way over here. And this is the whole reason why we're going to use FBOs, is we're going to chop it and cut it off to make sure that it only renders in here, not way over here and on top of stuff and all kinds of goofiness. And we need this FBO anyway so that we can render our cameras whenever we start the game window. So FBOs are really good to use because we can just reuse them. Alright, so let's go ahead and start that. FBOs are very simple, and we are going to basically just make the easiest version of an FBO we possibly can for the moment, because we just need to hurry this up because I'm way over the 30 minutes, and we have been, just because I'm trying to squeeze as much stuff as I can in tutorials before I go on breaks. I don't want to take off for a whole month and just leave it without rendering the scene. That would be dumb. So I'm just trying to get this stuff out of the way so we can focus on the better stuff later. So basically what this is we need a frame buffer ID, because we need to know which frame buffer we've currently got bound. And we need to have a reference to a texture of the texture that the scene is being rendered to. And that way we can render it using GUI. And here I'll just leave this as protected, because I don't want to come back in and change it later. And we're going to pass in an int width and an int height. And that way we can create the texture using that. So whenever we pass in width and height, we need to set its values. This dot height equals height, and frame buffer ID equals, we'll create some functions to do this for us. So create frame buffer, and next we need the texture ID. So int texture ID equals create texture attachment, because you need to create attachments which are going to attach to the buffer. That way it knows which texture is which. And new texture, pass in texture ID, width, and height, because we have a pre-built function inside of the texture class that allows us to create a texture by using the texture ID. It also just needs to know the width and the height for that texture. And then I'm just gonna have an unbind function, because whenever we create the frame buffer, we're going to have to bind it. So then at the end, we need to unbind it, because we're not going to be using it all the time. So firstly, let's have a way to get the image. And all that's going to do is just return the texture and keep it final, just so that we can't change it. Alright, so now that we got that, we can go ahead and create the bind frame buffer function. And this is going to be gl11.gl bind texture, and the target is going to be gl11.gl underscore texture underscore 2D. And then here we're just going to pass in 0, I believe. So we need to I think that's correct. I think I can just pass in 0 instead of passing in the texture ID. I don't know. We'll see. I believe we can do that. All right, GL 30 dot GL bind frame buffer. Then we need to pass in GL 30 dot GL draw frame buffer. And then it's going to be frame buffer ID. So then that's going to bind our frame buffer. All right, so then I'll do the unbind function. So public void unbind. And this is just going to be GL 30.GL bind frame buffer. And then GL 30 dot GL underscore frame frame buffer, and cache it to 0. Alright, let's create the frame buffer. I know I said that earlier and I ended up just doing the bind function. I'll go ahead and, yeah, because then we'll bind it, create it, yes. Sorry, I'm trying to hurry up, so I'm just kind of like mumbling to myself. And so now we need to get a buffer ID, basically. So it's going to be gl30.gl gen frame buffer, not buffers. Is it buffers? Oh, no, just because I didn't pass in anything. Wait, no. Yes, it is buffers. Okay. And then gl30.gl. What am I doing? gl30.gl bind frame buffer. Oh my god, I am really tired of. I think it's this one. So the target is going to be that one, and then what to do? Frame buffer ID. That's what I hate about lightweight Java game library and OpenGL in general. It always has these capital underscore BS, and I hate doing all that. It's so annoying. Alright, next thing you need to do is GL30, no, GL11 dot draw buffer. It's going to be GL30 dot GL underscore color underscore attachment 0. And then we're going to return buffer. Alright. There we go. Alright, there's the create function. Now that crap's out of the way. Alright, so now we need to create the texture attachment. So private int create texture attachment. Oh, more OpenGL crap. Int texture equals gl11 dot gl gen textures, and then gl11 dot gl bind texture. You know what? I really don't want to type all this crap again. Let's see here. Well, I'm going to copy this. And I'm going to put it right there, because we're going to need that anyways. And here the target is going to be gl11 dot gl underscore texture underscore 2D, and then texture. All right, and then right here. See here, do we have a GL bind texture? So I don't have to type it. Please God tell me I do. Right there. Copy. Paste this thing right here. Alright, so it's going to be texture 2D. It's going to be a 0 RGBA dot width, which I could just say width, height, 0 RGB. Yes, RGBA, GL unsized byte. We don't have data. So this is going to be a byte buffer null. Oh, come on, now you're going to freeze up. Okay. Import byte buffer. Now let's have... Oh, I didn't return anything. Here I'm going to... Oh, that's why it was doing that. I had caps lock still on. So then we're going to return texture. And then here, let's have a cleanup method. So public void cleanup. And this is going to be GL30 dot GL delete frame buffers, and then we're going to pass in frame buffer ID, frame buffer ID. There. FBO class is done for now. And no more OpenGL code for now. Thank God. Alright. Now, let me get my bearings together, and I'll be right back. Okay, I'm back. Let's get this done. Alright, so the first thing after the FBO class is created, now I need to be able to... Oh, God, come on. Come on now. Say FBO equals new FBO. Oh my God. Why can't I type? Equals new FBO. And then we need it to be application.width and application.height. So right here we're going to have a private static FBO. Alright, so now we've got the FBO created. What we need to do is we need to bind the FBO, and then we need to clear it so that it clears out the previous frame. So FBO dot bind frame buffer. Then we need to call GL clear, and we're not using a depth texture attachment right now. We're only using a color attachment. So need GL underscore color underscore buffer underscore bit. Now what are you complaining about? Hold on a second. Okay. And the reason was because of this right here. But like how I've complained about dozens of times, is sometimes it does not like register that it needs that. It's like, oh, I can't find it. Okay, so we're going to clear the color. We're going to clear it to black. So now we've got the color cleared. Or we've got the color buffer cleared. And we've got it cleared to black. And so now that the frame buffer is bound, then everything under here is going to be rendered to this FBO. So then we can call FBO.unbind. So we're going to unbind the FBO, meaning now anything under this unbind is going to be rendered directly to the screen. So we can call GUI.prepare, just to prepare the GUI again. And let's see. We need, of course, the width and height of the application. And that way we know where to render it. Really? Oh. I already have it up there, that's why. Okay, well, since it's already way up here, um, after prepare, we can call GUI dot draw texture with text chords. And here is going to be FBO dot image. And the drawing rectangle is going to be the R that we passed in. And now we need a UV for that. And the UV is going to be R.X divided by W, R.Y divided by H, and then R.width divided by W, and then R.height divided by H. Kind of like what we did earlier. And then after we draw it, then we can unbind the GUI again. Alright, let's see what happens now. I might have missed a step, but hopefully that... And it's not. So I'm doing something. Alright, give me just a moment again. Alright, I'm back. It was a twofer. Inside of the FBO class, under create frame buffer, right here I put frame buffer ID. It needs to be buffer. And I completely forgot this line right here, wherever, because this binds the texture to texture position 0 and the frame buffer. And after that, then it will render properly. See, it's right side up. And also, if we move this, let's say 250. Nope. Let's go 275. You see now it's trimmed off, so it will only render inside of this area. So now everything works except for rotation, which we will get to very shortly in our next set of videos in January. Sorry that this episode was so long and just flustered from all the Thanksgiving stuff all weekend. It's just it's kind of screwed me over, but we're able to jam this all in there. It's been over an hour, but now we have our scene rendering, so that is definitely good. And we have FBOs. We got a lot more of this OpenGL crap language done, so we don't have to worry about some of that. We'll add depth textures or depth texture attachments and stuff like that in January as well. And so there's a lot of stuff that we still need to do, but it will be coming up as soon as I come back. So I hope you guys were able to keep up or understand what I'm doing, and you didn't get lost or anything, because I was a little screwed up myself. But have a good Christmas and Happy New Year, and I will see you in January. All right, bye guys.